Hi, my name is Zodi Sanchez,
And my name is Ayomide Ayeni.
and this is our project Enhancing Security in Corporate Networks through Zero Trust Network Segmentation with Continuous Identity Verification. And these are some of the topics we'll be covering. So, introduction and motivation behind the project, background and related works, problems and shortcomings, proposed methodology, and the conclusions. So, in today's general interconnected digital landscape and just modern network connectivity systems, enhancing corporate network security has become increasingly important and relevant to protecting and safeguarding corporate client data, keeping shared data secure, and also ensuring that reliable access and network performance in the face of increasingly more complex cyber threats within network security as more attacks are being directed towards intellectual property and also causing network failures to interrupt business operations. So, in terms of the why and the how safeguarding against cyber threats in today's network security kind of came about and why it's so important is based on two different factors. So, network exposure and network robustness, where attacks are they're more often targeting networks with higher connectivity because of the potential to attack a more wide variety of nodes and edges and applications and to reach more of the critical systems within a network quicker. And they often rely on factors of poor exposure like connectedness, reachability, and centrality. And additionally, in terms of network robustness, malicious attacks are often directed towards weakening specific paths within the network to reach and gain that unauthorized knowledge and access to edges within the more critical parts of the system to cause more directed and pinpointed network failures. So traditional corporate network security often relies or revolves around the idea of perimeter-based approaches where only parts of the network are being safeguarded, and what they refer to this idea as is the castle and moat model, where it's using firewalls, intrusion detection systems, and also a lot of antivirus software to prevent that unauthorized access. But unfortunately, this kind of becomes a problem, especially as technology continues to advance and more modern networks are becoming moving to a more hybrid and cloud environment because they're often relying on data that's outside of corporate networks and their original perimeter that was being safeguarded. And they're also employees are able to access all these corporate resources from a diverse amount of devices and locations. And so this is where our project and our proposed methodology kind of comes in, where we're employing and encouraging zero trust network segmentation to address all these shortcomings with the traditional corporate networks. And essentially, zero trust security models, they operate under the assumption that no user should be automatically trusted. And they're using multi-layered approaches to access control or to limit the access to systems also and also employ continuous verification and authentication for users coming in and out. But unfortunately, zero trust models, they also have their own shortcomings and their own problems where that continuous verification, it can put limitations on application performance, difficulty in accessing core resources remotely, and also having to constantly assign these privileges later on, which is why our project decided to differentiate from the original or traditional architecture of zero trust models by implementing micro-segmentation to resolve not only the shortcomings of traditional networks, but also zero trust networks. And essentially, what microsegmentation is doing is it's dividing the network into smaller granular zones that require that zero trust inspection while reducing the amount of attack surface that can be implemented and preventing lateral attacks. It's also limiting the lateral spread of cyber attacks within more cloud and hybrid network environments and enhancing that security within the more critical parts of a system. And it's enabling that isolation of the regulated environments within the network to separate all this data. And by doing so, it's going to increase the performance of the traditional zero trust model by separating or isolating these security precautions in smaller zones while also implementing the zero trust authentication constantly. So now on to the proposed methodology.
So next we'll delve into methodology. First of which is the Zero Trust Network Segmentation Design, a critical aspect of cybersecurity strategy for corporate networks. And this involves crafting a detailed plan to fortify corporate networks by strategically dividing it into logical zones and microperimeters. And what's the goal? To enhance security by curbing lateral movements and containing potential security breaches. Now to the steps of implementing this. The first step is for the organization with the corporate network to identify and classify data and resources, and by understanding the sensitivity and the criticality of their data and resources, they can categorize their assets into distinct groups ranging from public-facing servers to internal databases and user workstations. Once the data and the resources are classified, security objectives for each zone is defined, and this entails establishing the necessary level of trust within each segment and implementing access controls to safeguard sensitive assets. Next, logical zones are designed based on the classification of assets and their corresponding security objectives. And this includes creating distinct areas such as a public zone for internet-facing servers, the DMZ acting as an intermediary between internal and external networks, the internal zone for user workstations and internal servers, and the sensitive zone housing critical servers and sensitive data. Within each zone, microperimeters are identified to isolate. Can you go to the next slide? Within each zone, microperimeters are identified to isolate individual assets or groups. And these microperimeters act as a crucial defense, minimizing the impact of a potential security breach by controlling lateral movement. Clear boundaries is defined between zones and microperimeters, and access controls are implemented based on the principle of least privilege, ensuring that only necessary communication is allowed. So embracing the principle of zero trust, we default to deny all communication. Only authorized traffic is explicitly allowed. Every user and device attempting to access resources undergo authentication and authorization processes. Selecting appropriate technologies for network segmentation is crucial, and this may involve the use of firewalls and VLANs, virtual LANs. So to maintain visibility within the segmented network, traffic inspection mechanisms is implemented, and this involves monitoring and analyzing communication within and between zones. The next slide, please. So right on top of the zero trust model, continuous identity verification mechanisms will be implemented. And the journey begins with selecting a multi-factor authentication solution that is tailored to the organization needs and infrastructure. This MFA solution is integrated into the authentication process for all users and devices accessing the corporate networks. And this ensures an additional layer of security beyond traditional passwords. To enhance security, a combination of factors such as passwords, biometrics, smart cards, or mobile authentication apps will be utilized. Then in parallel, behavioral analysis tools will be chosen that are capable of real-time monitoring and analysis of user and device behavior. So to set the stage, a baseline of normal behavior for users and devices within the network is established, and this involves analyzing historical data and defining thresholds for normal behavior. Next slide, please. So these behavior analysis tools are configured to detect anomalous activities, deviations from established baselines, and this includes unusual login times, access to uncommon resources, or atypical data transfer patterns. Real-time monitoring tools are implemented that continuously observe user and device interactions within the network, and this real-time visibility is crucial for proactive threat detection. Continuous identity verification is seamlessly integrated into the network architecture to ensure that user and device identities are verified throughout their interactions. So to adapt dynamically, mechanisms for re-authentication or or additional verification is established based on detected anomalies or changes in behavior. Then a comprehensive user and data profiles are developed that is encompassing attributes like roles and access privileges. So finally, to facilitate swift responses, alert mechanisms are configured that can promptly notify security teams of detected anomalies. Next slide, please. So based on this methodology that we just proposed, we anticipate a substantial increase in organizations' network resilience against potential threats. And by eliminating assumptions and verifying identities in real time, organizations can create a network environment where trust is earned and continuously validated. Also, one of the critical outcomes we anticipate based on this methodology is a significant reduction in the risk that is associated with data breaches and unauthorized access. Next slide, please. In conclusion, in a rapidly evolving threat landscape, the security of corporate networks is of utmost importance. Enhancing security in corporate networks through zero trust network segmentation with continuous identity verification will tackle the inadequacies of traditional network security models. And by implementing this innovative approach, we anticipate a significant improvement in network security, reduce risk, and enhanced access control. These are the reference papers that we consulted to be able to dive deeper into the topic and to gain more insight. Thank you for listening.